Hit it!
That's what I'm talking about.
Wait!
Okay, now, from the beginning.
All right, well, my name is Eric Keller, and I'm going to be demonstrating the Octane integration into Unity today. Thank you for showing up. I've been working with Otoy for about a year now. I'm a bit more on the visual effects artist kind of thing, but I'm moving, as the rest of the world is, more to game technologies. And how many of you guys have used Octane before in any capacity? I got a couple people. Have you used it in Octane in Unity? Okay, cool. And how many of you guys are actually game developers professionally? Everybody. Cool. We had a lot of big announcements this week in terms of releases for Octane. Octane 4 has just literally came out yesterday, and we have new builds of Octane for Unity coming out, and eventually within a short amount of time we're going to have the two will meet and we'll have Octane 4 for Unity. Right now I'm going to be using a slightly older build just because it's a little bit more stable. I want to make sure that everything is kind of clear. And I'm just going to kind of run through basically how to work with Octane for Unity inside Unity, obviously. So I'm going to minimize this really quick, and you can see that I'm using 2017.3, and what I have here is just a really simple scene with a little robot. And here I have the scene view, and here we have the PBR viewport, which is actually our Octane renderer in action. So as I move the camera around, you can see that it updates fairly quickly. And I believe this machine is running with a single 1080 Ti. So Octane is GPU based, so more graphics cards you have, CUDA based cards, that is, the more rendering power you have, and the faster the feedback will be. So when you're working with Octane for Unity, and once you have it installed, you will find an Octane menu up here, which is going to give you access to your main controls. Just as a quick aside, for information about Octane for Unity, including some demo videos, you can go to unity.otoy.com. So a web page is devoted just to the integration, and you can download via the asset store several free samples. So we have an installer scene. So by downloading this and installing this, and opening it in Unity, it will install the Octane renderer. And then we have a few other example scenes, including the famous courtyard, and then we have a kind of a Star Wars style docking bay with our friend the robots, and a little bit of a spaceship that's based on a space station based on the Unity logo, as well as some other demo scenes. So you can check these out. They're all free and available. And so what I've done is I've taken a few elements from the docking bay scene and just put it into a smaller scene just to kind of show things off a little bit. But when you have Octane available, if you go into the menu, the first thing you need to do once it's up and running is check out the settings page right here, is make sure that Octane is loaded. And down here it gives you basically an update on the graphics cards, what's being used, and their current status. Of course, we also have the inspector here. We can access all of our controls. But the first thing you need to do to the scene to get Octane going is to add a PBR render target. And you can add multiple PBR render targets to a single scene. So I have one here somewhere. There we go, PBR render target. And if you take a look at the inspector, we can see that it contains all of the settings necessary to run Octane within the PBR viewport. So if the PBR viewport is not currently open, you can obviously open it using the Octane menu, the viewport right here. And then when you press render, it will take a few moments to compile the scene, to load the geometry into menu, as well as into memory, as well as the textures. And then after a few seconds, you'll see your scene appear right here. And then it will continue to be active while you work in your scene. So you can edit things like materials and lighting and so on. So what I have in here currently is, with regards to the lighting in the scene, I have a directional light, It's the same directional light that you use in Unity, so all the Unity lights work just fine, but you can also add Octane lights, or at least emissive shaders. And you can see as I rotate the directional light around, we can change the time of day, and so on. And then I also have an emissive shader on this little sphere here that our robot is playing with. And so what I want to do is let's take a quick look at working with cameras. So if I have a main camera in here, I have a secondary camera, and I can add as many cameras as I need to. If I go to the PBR render target, under the camera settings here, I can switch between which camera I want to use. So I can use, right now I have it set to editor, so it's matching what I see in the scene view. If I switch over here to game view and then switch my camera to game, you'll see that it will update and we'll see the game view. Let's make sure that the set into custom here. There we go. And then below this we have our different types of cameras. So I'm using a thin lens camera, which is a nice way to say kind of like a normal camera. We also have a panoramic camera that will allow us to render 360s. And beneath the panoramic camera settings, we have different types of projections. So we have a large number of presets that you can use depending on the type of spherical rendering you want to do. And then we also have stereo options down here. So for example, if I wanted to do like an over-under rendering, you can see if I'm doing this for VR or something like that, it's very easy to set that up and render out something for VR or any other type of stereo rendering that you're doing. So for example, if I set this to thin lens camera, I can do stereo rendering from that. So let's disable this for the moment. And of course, within the camera settings, we have any number of other options, including perspective correction, focal depth, aperture. So if I wanted to activate something like depth of field blurring, I could increase the aperture. 100 is probably a bit much. And then, of course, we can also set the focusing. Up here in the PBR viewport, we have a number of settings. So obviously, I've set this to kind of a ridiculous level. So if I go up here and select the camera's focus picker and then click in here, it will select the focal point. So it's kind of interactive. And this is similar to Octane standalone. Let's set this back to 1. And down here we have our environment settings. So I currently have this set to the editor, which is using the directional light to create the lighting in the scene. Let's go back to scene view real quick. And so again, I'm using that directional light. But we can also add things such as we can break the connection to the default skybox and actually, I don't have an IPR in here, I'm sorry, HDR image in here, but you could bring in an HDR image and render out with a different environment. Set this back to editor. And then of course we have a number of options for if we want to do a texture environment. I don't think I have a texture loaded in here, so let's skip that for the moment. We have daylight environment, so I could also okay, so what I'm going to do is take a quick look at the render kernels down here. So the render kernels basically determine how the lighting is calculated in the scene. So Octane is a physically based rendering system, so it's physically accurate. We have several different types of kernels here. So the more physically accurate ones are the path tracing kernel and PMC. So if I switch to path tracing, depending on the type of materials that you have in the scene, especially if you're having reflective or refractive materials, that will be actually physically based, as opposed to direct lighting, which is a bit more of like kind of a brute force method. And then for the most physically accurate, but also the most intense, memory intensive, is the PMC kernel. So if you have a lot of things like caustics and that kind of stuff that you're trying to render, you can switch to PMC kernel. It's going to be a little bit slower. So what I want to do is, let's do this. I'm going to create a new scene really quickly within this project so we can take a look at some materials. So I'm going to create a 3D plane here. And let's just create like a simple sphere. And duplicate this a couple times, and then I'm going to go to the Octane menu and add PBR render target. Now let's just do a quick render. So you can see there's our 3 spheres. And if I go into the project here, let's just create some quick materials. So I'm going to create a new material. Let's just call this test mat. And drag this on here. I select this object, you can see test mat. So Unity materials will render just fine in Octane if you're using basically standard or any of the standard setups, so roughness, etc. But where things get really interesting, where you start to really get into the power of Octane, is when you're actually using Octane materials. So if I go into the shader here and set this to Octane PBR override, it's going to switch to an Octane style material. And what I can do is I can click on this button right here and add textures from the scene that are currently loaded into this project. And you won't see any change right here. You will see it right here. What I need to do now is I need to actually edit the Octane material itself. And to do that, I will click on View Source. And this opens up the Octane standalone interface. So within the Octane standalone interface, you have access to all the Octane materials, physically based materials. And you can see if I zoom out here, let's see. All right, of course the texture is not showing up. What I'm going to do is I'm going to create a material. Let's do, say, for instance, a glossy material. And I can start editing the colors of the material, and then the material quality, such as roughness, index of refraction. I can create other Octane materials, such as the specular material, if I want to do something like glass, transparent shader. Add the bring up the roughness to make it a bit more translucent. Change the index of refraction. And I also have access to all the procedural nodes that are available within Octane. So when there are textures, we have things like fractals, turbulences, which I'm going to plug into. Let's actually do this since that's not a transparent material. So I can start adding in any of the Octane materials. Let's see if I can get that texture to show up. Normally what you would see is a little texture node. For some reason it is not updating. So let's add a couple more textures here. Oh, I see. Okay. my mistake, sorry. When I added the texture, I had this set to Unity display texture so we could see it in Unity, but I need to add more textures to bring them into Octane standalone. So let me click on this little button right here. I'll just add a couple textures from the project. Something like that. And then if I go into view source, now you can see there are the textures right here. So I can start plugging these into the nodes down here. So you can see is when I'm working in Octane standalone, if you haven't worked in Octane standalone before, it's actually fairly straightforward. It is a node-based system similar to working within something like Nuke. Let's get rid of the bump texture here. Okay, that looks a little bit better. As I create nodes and add them into the scene, I can basically connect them up with wires to the materials right here, and you can see only the ones that are appropriate for that incoming connection will be available. And the different types of materials that we have available include diffuse, glossy, a mix, which we can blend materials together, a portal material, which is basically used for light openings and structures. So if you have light coming in through a window into a room, that will basically optimize the light calculation. So in this context, it's not particularly useful, but it is great for using, especially like architectural renderings, just to optimize lighting in the scene. Diffuse materials are excellent for creating things like emissive shaders, like I have in the ball in my little robot scene. So if I add the diffuse material and I go down here to emission, I can choose between texture or black body. It kind of depends on which you kind of prefer, but they will actually cast light into the scene. So what I should do in order to highlight this is, let's go in here to the directional light. There we go. And let's make it a little bit darker. There we go. And diffuse materials are obviously great for things that do not necessarily have strong specular highlights, so concrete and that kind of thing, dry concrete. But also this is what we use for our emissive materials. There are a couple materials that are not available in this version that are available in the upcoming version, and that includes a metallic material, which you can use for something that's closer to like a PBR workflow if you're using like Substance or something like that. So you have a specular map that you can plug like a metallicity texture. If you've created that in Substance, you can plug it into the specular map and you get a much more realistic metal. And it's a bit more of a familiar workflow if you're coming from sort of a game texturing side of things. And we also have several toon shader options, which will be available in the next version. So if you want to render with tunes. Do you guys have any questions right now? Feel free to ask if you have anything that you want to talk about. Is this all making sense to you guys? Okay.
I do a lot of stuff on mobile. Is this going to be just kill any mobile device? Basically.
That's a good question. Well, the question becomes, how do you actually transfer from this sort of physically based rendering into gameplay? At the moment, what you can do is you can actually bake all the lighting and the textures, and then you can apply that to your objects for real-time playing. So let's take a quick look at that. Now, of course, with the Octane 4 and the improvements we're doing to speed, we're incorporating things like an AI denoiser in the next version. So the direction that we're going is more and more towards real-time working with Octane in the within Unity. And there's even some interesting demos. If you go to the, if you sign up for the Octane Render Facebook page, you'll see it's actually one of the best places to get the latest information, and there's a lot of really cool stuff being posted there by our developers as well as Jules. The other day, I believe it was Haysam posted a rendering that he was showing on a phone. It was iOS Octane rendering. I don't know how he did it. It's kind of crazy magic, but it's something that's worth checking out. Let's go back to a little robot here. The other thing that is going to be available very shortly, it's still in the process of being completed, is our Octane light mapper. I'm not going to be able to show that today, unfortunately, but I can show baking. So the light mapper will allow you to streamline the baking process. Right now I'm going to show you kind of baking on an individual object basis. So let's do a quick render here just to compile the scene. So if we take a look at let's take a look at the floor object here, and it's currently set to a PBR override. So to actually bake this lighting that you see that's being created from this emissive texture and the shadowing, etc., onto the floor, the first thing I want to do is select my floor object, and in the inspector, I want to set the baking group ID. So I'm just going to set it to something that easy to remember, like 100. And then I'm going to go into the PBR render target and set my camera. So I've added a baking camera right here. And I'm going to set the type of the camera to baking camera. And you can see right now it's rendering everything at once. What I need to do is set the baking group ID to match my surface there. So I'm going to set this to 100. And you can see now the floor is being baked in the texture. Of course, the other thing I wanted to do is make sure that my film settings are set to a nice square texture. So they are. It's 2048 by 2048. And then what I can do is I can activate render to texture. So I'm going to actually have one here already. So what I'm going to do is let's just set this to none real quick. And I'll choose create new, and I'll just call this floor. Let's call it floor 2. So now then what you'll see in the project under assets is we have floor 2 is available right now. And if I start to, say, move the lighting around, you'll see that the texture updates. Of course, the more GPUs you have in the machine, the faster this updates, and it can also end up looking like near real time. And again, just to sort of mention, as we, with Octane 4, as we integrate the Octane, the AI denoiser, what that's going to do is clear up the noise much, much faster, so you'll have to use fewer samples in order to get a clear image. And there's some really cool demos that Jules has online showing him sort of working the AI denoiser with very, very few samples. So if I could take a look in the hierarchy and go to PBR render target, under the kernel settings, let's set this to direct lighting. I have my max samples right here set to 500, which is, you know, a medium decent quality. If you're rendering for visual effects, it's not unusual to have this set up to, you know, a few thousand samples, depending on the scene, the number of lights, and that kind of thing. With the AI denoiser, you can set this down to as low as something like 4 or 5, and you get a very clear image very, very quickly. It's near real time. So it's something that's worth checking out online and see some of the videos that Jules has done. So I'm going to create a new material here. And apply it to my floor here. And I'm going to set this to unlit texture, and then for my texture, select that floor texture. Actually, what I want is floor 2. And it's kind of cool because you can see that now that I have that texture that's being baked applied to the floor and then reapplied to that material, as I move the lighting around, you can see the lighting updates down here. Of course, it's not doing as nicely as I'd like it to.
Since it's unlit, shouldn't it be as bright as it was before?
Yeah, I'm not sure exactly why that's not. What we can do is, let's try this.
Updating your texture file.
Yeah, it should be doing. Not exactly sure why it's not and so bright.
Because it's still Octane shooter.
Oh yes, why is it? I thought that I did this. Yeah, it's not working the way that I want it to. I do have a video online that shows how to do this correctly. I'm not sure why it's not behaving.
The workflow is though you basically bake it within the engine to a texture.
Yeah.
You can apply it, and then you basically just turn off Octane renderer, and now you're seeing sort of pretty, but.
Yeah, exactly. What I'm trying to do is a little bit fancier than what I should be doing, which is I should just set this to. Yeah, I'm going to do this. I've kind of messed it up a little bit too much. Yeah, set the baking group ID here. And go over to the PBR render target. I'll set the camera to baking camera, and then set this to 100.
Is there a reason why you have a separate camera for baking?
I just set that up just for convenience. You could use any camera that you wanted to, so if you just have one camera in the scene, that's fine.
Switch the render target and switch it back.
Yeah, yeah. And like I said, you could also have multiple render targets. So you could have a render target that's set to direct lighting or one that's set to PMC or path tracing. They could have different environments, and so you can switch between them fairly quickly, which is kind of cool. Yeah, so if I go back to render to texture, let's set this to... I'll create new, and I'll just call this so there's my baked floor texture. So okay, oh, there we go. Yeah, I think what I'm, okay, sorry, I apologize.
Change something in your PBR.
It is, and I know exactly what it is. I made a mistake, sorry about that. What you need to do is before you apply the shader, I need to set this back to none, because what it's doing is it's baking the texture, and so I'm getting kind of a loop going there, so I apologize for that. Come back to the project here, materials. Let's do this one more time. Okay, so now I can see that we have floor 3. So now that's baked in terms of the texture. So now the step that I missed before that I should have done is once it's baked, I should set this back to none so it's not overriding that texture as it's rendering. So now what I can do is add on that floor here and make sure that it's using the right texture. There we go. So obviously it's going to be static. You can sort of create a loop where you have an unlit texture that's using that texture while it's being baked. It's a little bit tricky though, but this works really well if you're going to do like a static scene and you want to bake in the Octane lighting and texturing and that kind of stuff. Is there any questions on that? I went over it like 6 times. Go ahead.
Are there any difference for using Octane lighting or Unity lighting?
Actually, not a whole lot of difference. In fact, you can use the main difference, I would say, is whether you want to use an Octane, sorry, a Unity light or an emissive shader. So Octane within Unity doesn't have its own types of lights. It's basically, but if I let's add a new light. I believe the lights that you want to use are directional and point light. I believe area light works as well, but let's add a point light in here. And let me switch my camera back. But you can also use emissive shaders, Unity shaders. So if you have a Unity shader that has emissive turned on and you set the HDR to 100 or something like that, it behaves very much like an Octane emissive shader. It doesn't have quite as many options, but it can look really nice. Let me set this back to... What I'll do is I'm going to take this guy and turn him off for the moment. Let's also go into the project here and get our original floor material back. Okay, so you can see I'm using a Unity light there, a little bit on the bright side, but you can see that it is functioning. So let's set the intensity deck down to, say, 1. Set the range down to like 5. I'm sorry, say that again?
Speed of rendering Unity lights.
I don't think there's, I think Unity lights might be a little bit faster than emissive shaders. It just, if you're using an emissive shader that has like a texture, I think that adds, a little bit of extra calculation. But if you're using Unity lights, they tend to be, I think, a little bit faster. There's just not quite as many options for doing special effects and that kind of thing. Speaking of which, what I should do is, I have some emissive shaders in this guy's eyes as well.
So are there use cases right now of choosing when to use Octane Render versus not, or is it more just it adds extra steps to your workflow, so unless you really want that level of detail, like, I mean, is the end goal, I guess, ideally to have it kind of every realistic, non-stylized?
Yeah, right now that's the best use case if you want to do something that is realistic and essentially getting this kind of quality in a Unity scene. Now, the best currently, since it's not quite real time, the things that you can do with it, obviously you can do the baking like I was showing. We also have the Octane recorder, which allows you, if you have several animated cameras or animation in your scene and you want to render out a sequence similar to doing like a batch rendering and like something like Maya or Cinema 4D, the recorder will allow you to do that. The recorder actually will play through the game and render each frame to disk. So that, I think the most obvious use for that would be something like a cutscene, or if you wanted to kind of show, do sort of like a beauty shot to sort of advertise your game and that kind of thing.
So then in runtime, do you play it as a video or in
It saves out to either PNG sequence or EXR, which you could then edit in a video editing software or put it into animation. The other thing I wanted to kind of show is, there we go, turn that back on, is the, in the PBR render target, some of the other sort of special effects that you can add down here in the post-processing. So we have our own post-processor built into Octane, so you can add things like bloom and glare and vignetting and spectral shift.
May it be combined with Unity post-processing stack?
We're working on a system right now where you can integrate Unity's post-processing stack into Octane, so that you would have an Octane render and then the post-processing stack on top of that. But it's still in the process of being worked out. We should have a video on that within the next couple weeks that will show sort of the process of going through that, as well as some of the baking and other options that we're having within Octane for Unity.
So that's applying the post-processing to everything that camera sees, or?
Yeah, what you would do is you would basically turn off all the, obviously the Octane post-processing, and then you would be rendering through Octane, and then in the game view, you would see the Octane render with the Unity post-processing stack on top of it. I think we have it working and it looks pretty nice. It's just we're streamlining the system so it's a little bit faster. And again, that would be really good for rendering out things like sequences, like if you wanted to do something like Atom, taking advantage of Cinema Machine to create, basically to use Unity as an animation tool, or like as a cinematographer might. So that's kind of where we're going with that. Within the imager, we have color correction. What I want to do is I want to bring back my original floor here. Here we go. Did want to kind of show a little bit of the let's create a cube here.
Octane works with hair rendering on painting.
Say that again?
Octane works with hair rendering.
Octane, the way I've used it, Octane does have a hair shader built into it. I haven't used it with any kind of Unity hair. Since I'm more of a visual effects person, I tend to use it with like Maya paint effects, and it works quite well. But we will be updating the Octane shader so it supports more different types of primitives. Currently, what you would do is you would apply the Octane shaders to the hair curves or the hair geometry, and then tag it with the Octane hair shader, and then it would render in Octane. In terms of how you would use that in a Unity workflow, I haven't tried that yet, so I can't sort of speak to that. But all right, never mind. I'm not going to do that. I guess what I can do is talk a little bit about working with the materials. So currently on the robot, I'm using these are all Unity materials right here with just some basic textures. So I'm going to switch this over to Octane PBR override. And I've actually already set this up previously, so I've added all the textures. You can see, though, that we get a nice reflective surface here in the render view. It looks a bit more metallic. And then if I want to edit the material, if I go to View Source, you can see I have a glossy material set up with my various textures that I created in Substance. Let's see. There we go. And create a couple other materials here. So I'm going to create a specular material. And let's lower the reflection a little bit. And increase the roughness. You get kind of a frosted glass look on there. So I'm just lowering the roughness on the surface. So it's a transparent surface, kind of glass-like. So as I increase the roughness, I get something that's a little bit more translucent. And then obviously I can change the index of refraction and create some interesting looking materials, reflective and transparent materials. And then of course I can mix the two materials together. I can create a mixed material and then blend these two together. So it's kind of like a layered shader. And then within the mixed material itself, I have a mount slider, so I can slide this one way or the other to create sort of blend between those two surfaces. So if I slide it all the way to 0, I'm getting that specular material. If I slide it all the way the other way, I'm getting just the original glossy material. And of course I can also add things like textures to this to control the amount of blending. So if I wanted to do like a dirt texture or something like that, the dirt's kind of like ambient occlusion type texture. So I don't know, it's kind of interesting. Let's do this. Oh, it's kind of interesting, but let's go back to our original glossy material. Let's see if we can create a nice sort of water type material here. So I set this to Octane PBR override. Add a specular material. The index refraction 1.33. So you can see you can get some really nice looking water type effects or glass type effects fairly quickly. And again, they are physically accurate if you're using the PMC or path tracing. Add a little bit of a turbulence to the bump here. Yeah, so you can get some kind of cool, interesting looking materials that way. Any other questions? Cool. So I encourage you guys to go check out unity.otoy.com and download some of the example scenes. Let's see if I can open up the docking bay here, because it's kind of a cool scene. It obviously it depends on the size of the scene, the amount of GPUs that you have. Like I said, as we release Octane 4 with the AI denoiser, that's going to reduce render time considerably. Because one of the great things about Octane is that you essentially get an image very quickly, so you can do look development very, very fast. Where the time comes in is basically reducing that noise. So the AI denoiser is meant to reduce that time significantly. So eventually, right now, depending on the scene, you can have something that renders in just a few seconds, but as we incorporate things like Brigade and other technologies, it's going to be closer and closer to real time. So it's a hard question to give a definite answer to, but the goal is eventually to have this type of realistic quality in real time. And of course, it also depends on the time of the size of your scene and the length of the animation. Let's see if this is actually working. Oh, there we go. Okay, cool. Yeah, so thanks very much for watching. I think that's all I have for right now. I appreciate it.